Hey guys, welcome. Yeah, so example 2 here, and this time it is this function whose Maclaurin series we need to find. Hey guys, welcome. Yeah, so example 2 here, and this time we have to find the Maclaurin series expansion for this function. Now, it might not be clear how we get started, but it should be clear that we need to somehow make use of the Maclaurin series for ln of 1 plus x. And in order for us to be able to use the Maclaurin series for ln of 1 plus x, we need to modify this first using log rules. In particular, we're going to use what's called the quotient rule for logs and then the power rule for logs. I have many videos out on logs. They're one of my favorite things, and I proved the quotient rule, the power rule, and the product rule for logs in videos I made a while back, so check them out if you want to. But yeah, using first the quotient rule for logs, we can write this, and then writing this root 1 plus 2x as 1 plus 2x to the 1/2 power, we can use the power rule for logs and write this. So this right-hand side is the same as this left-hand side. And now looking at this right-hand side, I'm more hopeful that we'll be able to use the Maclaurin series for ln of 1 plus x. Now, what was that again? The Maclaurin series for ln of 1 plus x is this here, yeah? And so first, to get the Maclaurin series for 1/2 ln of 1 plus 2x, we could replace this x with 2x and then multiply by a 1/2 in front. And doing that will mean inside of sigma, we replace this x by 2x and multiply in front of sigma by 1/2. So doing what I just said mean like this. Yeah, and if you simplify all the way, you can in fact put the 1/2 inside and have this n have company with that 2 right there. And otherwise, it should be pretty straightforward how you get to this end, right? Okay, cool. And then now we similarly deal with ln of 2 minus 3x, but note that for 1/2 ln of 1 plus 2x, we already had inside ln of 1 plus stuff. We already had inside ln, sorry, I misspoke. We already had inside ln 1 plus stuff. But inside this ln, we don't have 1 plus stuff. And we need that. We need 1 plus stuff. So to make that happen, first, inside of this ln, we factor out a 2, meaning we write this, and then use the product rule for logs, which is the only log rule we hadn't used so far. And it says that we can take a product and write it as a sum like this. And like I said, I have examples and even the proof of the product rule, so check them out for logs, right? But anyway, it allows us, the product rule for logs, to turn this into this. And we like this version, right? Because now I have ln of 1 plus stuff, where stuff is minus 3x over 2. And now I know how to deal with this part. The ln of 2 we're just going to set aside, and let's look at the Maclaurin series for ln of 1 minus 3x over 2. How do we get there? Well, this, right? ln of 1 minus 3x over 2 is like ln of 1 plus negative 3x over 2. So all we have to do is come to the Maclaurin series for ln of 1 plus x and replace this x with negative 3x over 2, meaning replace this x here with negative 3x over 2. And then doing that and simplifying will mean you get this, right? Meaning like negative 3 x over 2 is like negative 1 to the n, that's that. And then 3 to the n, that's that. And then x to the n divided by 2 to the n, but dividing by 2 to the n means we have to throw the 2 to the n downstairs with this n right there, yeah? Okay, so this should make sense. And now negative 1 to the power n plus 1, and then negative 1 to the power n can be written as negative 1 to the power 2n plus 1. Yeah? Okay, cool. So if we do that, then that means the Maclaurin series for ln of 1 minus 3x over 2 could be written in this fashion. And notice that the Maclaurin series for this ln of 1 minus 3x over 2 is different from the Maclaurin series for ln of 2 minus 3x only by this ln of 2, right? Otherwise, ln of 2 plus ln of 1 minus 3x over 2 equal ln of 2 minus 3x, and therefore the Maclaurin series for ln of 2 minus 3x is going to be ln of 2 plus this here, right? Okay, cool. All right, just making sure everybody's on board. All right, now we need space, so let's make space. And it is now clear where we're going to go. This here, right here, right? 1/2 ln of 1 plus 2x minus ln of 2 minus 3x is the same as this here, right? It's the same as ln of, you get it, what we had to start, right? Okay, but it's also the same as taking the Maclaurin series for 1/2 ln of 1 plus 2x, which is right here, and then subtracting from that the Maclaurin series for ln of 2 minus 3x, which is ln 2 plus this stuff. So subtracting ln 2 plus this stuff means subtracting ln of 2 minus 3x, and that's what I've got right here, yeah? Okay, cool. Now, we actually want to know how we can subtract them, right? And to actually in practice subtract them, we want to look at the terms, right? And so taking the terms for the Maclaurin series for 1/2 ln of 1 plus 2x right here in maroon, and then subtracting this, the minus ln of 2 is right there, and then subtracting this here would mean doing that, right? And you can do this more carefully, which is like you can plug in n equals 1, n equals 2 into ln of 1 minus 3x over 2 right here to see that these are, in fact, the terms. They're all going to be negative, but we're subtracting them, so soon enough, they're going to all be positive, right? Okay, cool. Now, next is, well, we can simplify stuff here in maroon. Specifically, 2x over 2 is just x, and yeah, you get it. And then we've got minus ln of 2, and then here we distribute this minus sign, which, like I said, is going to turn all these guys behind ln of 2 positive, right? Cool. And then we should combine like terms, meaning that we should do something like this. Well, let's lead with the minus ln of 2, and then, because it's the only constant term, right? And then put all the other like terms next to each other. Like the like term for this maroon x is this 3x over 2, and so on, right? And then we combine like terms, and we write this. Now, the ln of 1/2 is because, well, this is negative 1 times ln of 2, this minus ln of 2. But by using the power rule in reverse, we can write that it's the same as ln of 2 to the negative 1 power. But that's the same as ln of 1 over 2 to the positive 1 power, or ln of 1/2. And so that's why we've got that there. But otherwise, 3x over 2 plus x is going to be 5x over 2. And similarly, the other like terms combined to these guys. And this is it, right?